Hey ladies and gentlemen, today we're going to finish up the notes that we started yesterday, which is for Unit 8, Day 2, and that's evaluating trig ratios on the unit circle. So if you remember yesterday, we started by filling out the unit circle again for some additional practice. We talked about different tips and strategies we can use to remember those. Then we came up with this set of rules or these guidelines that we can utilize in order to use the unit circle to help us find different trig ratios like sine, cosine, and tangent. So cosine was the x-coordinate, sine was the y-coordinate, tangent was sine over cosine, or the y value divided by the x value at that angle. We talked about how we can simplify division problems by multiplying by the reciprocal when that was necessary, and how to rationalize if our square root was on the bottom. And then we discussed that anytime 0 is on the top of a fraction, the final answer is 0, whereas if 0 is on the bottom of the fraction, our answer was going to be undefined. So we talked about how we can do some of these problems, like if it's asking for the sine of an angle, we just go to that angle on the unit circle and write down the y value of that coordinate. If it asks for the cosine value, we go to that angle on the coordinate plane, on the unit circle, and we just write down the x-coordinate. If it wanted tangent, then we broke that down a little bit further. So if it wanted like the tangent of 300, we did sine of 300 over cosine of 300, and then we found those y and x values respectively and did our division and simplification. Okay? So these are the problems that we did yesterday. We didn't finish all of them, so I wanted you to see what those look like in the event that you wanted to go back and practice those, or if you already did them and just wanted to see if you did those right. Now, what we're going to be talking about today is what we call reciprocal trig ratios. So, as we talked about yesterday, a reciprocal, by definition, is just anytime we have a fraction, we flip the numerator and the denominator. So the top becomes the bottom becomes the top. We have what we call reciprocal trig ratios. So these are going to be 3 new words, but they're going to be tied to words we've used before, like sine, cosine, and tangent. So for example, the reciprocal of sine has a special name. That's called the cosecant. And we abbreviate that as CSC. So the reciprocal of sine is called the cosecant. The reciprocal of cosine is just called the secant, and that's abbreviated as SEC. And lastly, the reciprocal of tangent is called the cotangent, and that's abbreviated as COT. Now, new words might seem a little intimidating, but really in the end, all we're going to be doing is the same stuff we were doing yesterday, but we're taking one more step, which is whatever the final answer is, we're just going to flip it or take the reciprocal of it at the end. Okay, and that's what that note says. To find reciprocal trig ratios, find its corresponding ratio, and then take the reciprocal of it. So, for example, if we want to know what the cosecant of 30 degrees is, we first think cosecant goes with sine, so we're going to find the sine of 30 degrees first. The sine of 30 degrees is 1/2, so I'm going to take that answer and do the reciprocal of it. So if sine of 30 is 1/2, the cosecant of 30 is the reciprocal of 1/2, which is 2 over 1, or just simply 2. Okay, so after a couple examples, it'll become a lot clearer. We'll feel pretty good about them. So let's take a look at some of these. Okay, first one we're going to take a look at is the secant of 330. So the first thing we ask ourselves is which one secant goes with. So secant goes with cosine. So what we're going to do first is we're going to find the cosine of 330 degrees. And remember, we do that by figuring out we're going to figure out where the x value is at 330. So at 330, I can see the x value is root 3 over 2. And then all I'm going to do is take the reciprocal of that. So the secant at 330 is 2 over root 3, which is the reciprocal. And then we just have to take that step to rationalize. So remember, when we rationalize, multiply the top and bottom by whatever that square root is on the bottom. And multiplying across, we get 2 root 3 on top. And the root 3 on root 3 gets rid of the square root on the bottom. The secant of 330 is 2 root 3 over 3. Okay. Let's try a second one. For the cosecant of 60 degrees, again, the first thing we do is we determine which one cosecant goes with. And I can see that cosecant goes along with sine. So first thing we're going to do is we're going to find the sine of 60 degrees. Remember from before, sine is the y value. So root 3 over 2 is our answer for sine of 60. But we want the cosecant, the reciprocal. So the cosecant at 60 degrees is 2 over root 3. And that's the exact same thing we had before. So we know that in the end, this is going to end up simplifying to 2 root 3 over 3. Okay. Now, take a look at a cotangent example. Cotangent obviously goes with tangent. So instead of finding the cotangent of 150, we're going to find the tangent of 150. This is the one that requires the most work because we have to split this up. The tangent of 150 is the sine of 150 over the cosine of 150. So that comes out to be at 150, the sine is 1/2. The cosine is negative root 3 over 2. And now we go about our multiplying by the reciprocal. 1 over 2 times 2 over negative root 3. We can see that the 2's are going to cancel out. We're left with 1 over negative root 3. So I multiply the top and bottom by that bottom value. Negative root 3, negative root 3. And in the end, this comes out to be negative root 3 over 3. Now, that again is the tangent value. So, in order to find the cotangent value, we are going to do the reciprocal of that, 3 over negative root 3. And one more time, we got to rationalize. So multiply by negative root 3 on top and bottom. On the top, we get negative 3 root 3. On the bottom, the two negatives cancel out. The two roots cancel out. We're just left with 3. And we take the last step, which is a 3 on top, a 3 on bottom, cancel out. We are left with negative root 3. So, by far, the most work comes from a cotangent problem. That's probably going to be the worst one we would have to deal with, something like that. Okay? So, let's take a look at 3 more going across a little bit faster, and then I'll have you try the bottom 3 on your own. You'll pause the video, work on them, and then resume the video when you're done to see how you did. Okay? Cotangent at 240. So the first thing I want to do is I want to find what's the tangent at 240. So that's going to be the sine of 240 over the cosine of 240. And at 240 degrees, the sine is negative root 3 over 2. The cosine is negative 1 over 2. So when we go to simplify this, it's going to be the negative root 3 over 2 times the reciprocal 2 over negative 1. Right away, we should see the 2's cancel out. We have negative root 3 over negative 1. The negatives cancel out, and we're left with just a root 3. Now again, that's the tangent of 240. So the cotangent of 240 is going to be the reciprocal of that, which is 1 over root 3. And we just want to rationalize that. Multiply top and bottom by root 3. And we get a root 3 on top with a regular 3 on bottom. Okay. And that's cotangent of 240. Secant of 90. So we have to think which one does secant go with. Okay, the more we do these, the faster they'll go. Secant goes with cosine. So we're going to find the cosine of 90 first. So at 90 degrees, we look at the x value and we see that it is 0. Now, we want to be thinking about what the reciprocal of 0 is. So 0 as a fraction would just simply be 0 over 1. Therefore, if I want the secant, I want the reciprocal. So that's going to be 1 over 0. And as we discussed in our lesson yesterday, anytime 0 is on the bottom, that is undefined. Okay. So something worth noting is that 0 and undefined are reciprocals of each other. Okay, and that might be worth noting somewhere up here at the top. 0 and undefined are reciprocals of each other. Okay. So that'll simplify some stuff later on potentially. Okay, another one here, cosecant goes with sine. So we're going to figure out what's the sine of 270 first. Go to 270, and it's the y-coordinate, negative 1. Okay. So if the sine of 270 is negative 1, I want to take the reciprocal of that. So negative 1 as a fraction is just negative 1 over 1. So the cosecant of 270 is the reciprocal 1 over negative 1, which simplifies to negative 1. So at this time, we have 3 more examples, one cotangent, one cosecant, and one secant. Use the examples above and the notes provided to get answers to each of those 3, and then pause while you do the work. When you are done with and have your answers, go ahead and resume the video to see how you did. For cotangent of 180, we start by finding the tangent of 180, which is the sine of 180 over the cosine of 180. The sine of 180 is 0. The cosine of 180 is negative 1. So 0 divided by negative 1 is 0. This is where we can use our shortcut. If the tangent is 0, the reciprocal of 0 is undefined. So the cotangent of 180 is undefined. For cosecant, that one goes with sine. So we're going to find the sine of 225 first, which is the y value, negative root 2 over 2. And we are going to then take the reciprocal of that. Cosecant of 225 is the flipped version, 2 over negative root 2. Multiply top and bottom by that negative root 2. And when we do that, the top will be a negative 2 root 2 over this negative and this negative cancel out. That root and that root cancel out for a 2. And then the 2 on top and the 2 on bottom cancel out. And we are left with a negative root 2. Now, lastly will be the secant problem. Secant gets paired with cosine. So the cosine of 135 is the x value at 135. Cosine of 135 is negative root 2 over 2. And as we can see, that whole process will be the same as before. We had negative root 2 over 2 there, so it'll be the same thing. Therefore, in the end, we have the exact same answer. Okay, so definitely a little bit trickier. There's more rationalizing. And then what we can do tomorrow is talk about a way to maybe make that a little bit easier, but it is important that we see how we do this with this structure. So if you have any questions, feel free to shoot me an email or a message in Schoology. The homework is available in Schoology in the homework folder, so make sure now you open that up, get that done. You should have enough time to get that done and submit it before you leave today. Okay, thanks for listening. I'll see you guys tomorrow, and if you have any questions, let me know. Have a good day.